It is 2:47 a.m. 6 inches of water covers a finished basement floor. The homeowner files an $8,400 damage claim directly from their phone. The moment that upload completes, a chain of AI specialist agents wakes up. They have exactly 11 minutes to either execute a direct payout or freeze the claim in a queue for a human adjuster who arrives at 9 a.m. The math governing those 11 minutes is entirely asymmetric. If the system mistakenly pays a fraudulent claim, the carrier absorbs a 1x financial hit to its loss ratio. This table outlines the much steeper cliff on the other side. Denying a legitimate claim via algorithm, without human review, triggers bad faith litigation in 49 U.S. states. Those damages can exceed 3 times the original policy limit. The cost of a false negative dwarfs a false positive. That asymmetry dictates the absolute primary rule for automation in this domain. The architecture must escalate liberally and auto-reject rarely. This chart positions our solution within the development tree. We are applying Agent 08, the Chain-of-Agents Orchestrator, to construct the multi-agent insurance claims workflow. The central engineering challenge here is not fanning out parallel tasks to a swarm of LLMs. The challenge is safely reconciling conflicting data from those tasks without exposing the carrier to a class action lawsuit. This diagram outlines our solution, a typed interface directed acyclic graph, or DAG. It replaces loose agent swarms with an entirely rigid structure. The DAG guarantees execution order and item potency across 5 highly specialized subagents. Data only moves forward through specific predefined pathways. The manager unit, the agent assembly and decision routing blocks, never touches raw data. It does not read PDFs or process JPEG metadata. Instead, the orchestrator acts purely as a router. It accepts structured JSON payloads and confidence scores from the individual analysis nodes, moving data envelopes from state to state based on strict thresholds. Every transition is written to a shared memory whiteboard. If a process drops, the claim state is preserved and fully recoverable without requiring the user to start over. Contrast this with a naive agent swarm, where models hold open-ended conversations to arrive at a consensus. Unstructured chat logs cannot be audited. Regulators require exact deterministic records of how every coverage decision was made. Structural rigidity is the feature, not a limitation. The DAG format provides the mathematical guarantee necessary to clear a market conduct exam. Let's trace that 2:47 a.m. basement claim through the graph. The raw photos and user input hit the intake agent first. The intake agent runs a hybrid OCR pipeline, followed by a fine-tuned BERT extractor. It pulls exact fields from the image and attaches a percentage-based confidence score to each extracted value. The rules of the DAG require absolute certainty on core variables. If a critical string like the policy number parses with low confidence, the agent does not guess. It triggers an immediate escalation to a human. Assuming clean extraction, the JSON moves to the validator agent. Here, a deterministic track runs binary checks. Is the policy active? Does the loss type match the coverage? If these fail, the claim auto-rejects. Simultaneously, the probabilistic track uses DBS scan clustering. It scans for geographic and temporal fraud rings, comparing the new claim's zip code, timestamp, and payout amount against a rolling 48-hour window. This creates a critical system conflict. The claim documents look entirely legitimate, but the DBS scan cluster lights up, identifying 7 similar claims in the same neighborhood since midnight. The architecture explicitly prohibits the validator from rejecting the claim on suspicion alone. Instead, it applies a heavy mathematical penalty to the downstream classifier's confidence score. The base 0.96 confidence assessment takes a 0.40 penalty from the fraud flag, collapsing the final score to 0.56.
The system requires a strict 0.85 to execute an autopay. The threshold fails. The orchestrator safely routes the penalized payload into the pending human review queue. This landscape map highlights the exact companies deploying these multi-agent systems into production in 2026. Point solution specialists operate as individual nodes in these graphs. Tractable handles visual vehicle damage assessment via computer vision, while Shift Technology targets subrogation and claims fraud detection. Platforms like CCC Intelligent Solutions provide the core workflow orchestration.
Their systems act as the digital floor where these third-party agents plug in and execute. Meanwhile, vertically integrated AI-native carriers like Lemonade process over half of their claims completely autonomously, with zero human intervention on the happy paths. But the rapid expansion of autonomous straight-through processing operates directly against incredibly severe and mounting international regulatory headwinds. The first enforcement phases of the EU AI Act place strict transparency requirements on high-risk insurance systems. In the US, state-level regulators demand frequent bias audits and full model explainability. Because insurance is locally regulated, the orchestrator requires per-jurisdiction deployment validators. A DAG that legally processes a claim in Texas might violate notification timelines in California. Building an agent that can read an invoice is now baseline functionality. This dashboard tracks the specific top-line impact of this architecture. Carriers deploying straight-through multi-agent processing are recording up to a 68% drop in cost per claim on targeted lines. Those unit economics are driving the global insurtech market toward a projected $23.5 billion valuation. This timeline charts the compression of the space. In exactly 3 years, the industry shifted from isolated pilot programs to scaled production-grade agentic workflows. We have evolved from Agent 07. The central vulnerability that remains is miscalibration. If the 0.85 autopay threshold drifts, the carrier will either hemorrhage cash to coordinated fraud rings or drown their human adjusters in false positives. The system requires continuous Brier score monitoring to track the accuracy of its probability estimates. Scheduled recalibration via plat scaling ensures the confidence percentages remain tied to reality. Fraud rings adapt to static detection signals. An agent architecture that cannot dynamically measure its own error rate will rapidly become a target. In the next episode, we take this exact graph and embed it into agent number 09, long-running, durable workflows designed to survive server restarts and span weeks of continuous operation. The orchestrator acts entirely as a film director. Check the primary text for the full code implementation of the claim validator and the routing logic. When reconciling complex logic across multiple specialized models, remember the core principle of the orchestrator. The disagreement between agents is not an error. The disagreement is the discovery.